So you're going to have to be able to change square roots, cube roots to rational exponents. Maybe you remember that. We'll do that first. I have a 7, I have a 3, and I have, instead of a cube root, I'm going to put brackets, put what was inside the cube root in brackets, and change the cube root to 1/3. Now that 1/3 will apply just to the x squared. It doesn't apply to that 3 because of the way that it's written. I can write that again now, and most of you will be able to go directly to this step right away, because the 1/3 times the squared would give you 2/3. The x is still on the bottom of our fraction. So now I'll move it to the numerator by using my negative exponent laws. And now we're in a position where we can differentiate. Now when that negative 2/3 comes out in front, and I'm just going to write that like that, sort of using that constant definition, and I subtract 1 from my exponent, I'll get negative 5/3. Again, many of you will be able to directly go to multiplying that fraction of negative 2/3 times the 7/3, forgot the prime sign, and get negative 14/9 x to the negative 5/3. Sometimes I get excited about the next question if I ever go too fast. Did I go too fast? You weren't done writing? Just let me know. I will go back. Don't feel bad about that. I just look at the next one like, oh, this is another good question. Can't wait to do it. Now, can you think backwards? If I tell you what the derivative was, can you think what the original one was? So the derivative is 5x to the 4. Any suggestions of what? X to the 5. Question, does that work? Excellent. We're also going to find later on that this isn't the only one that has a derivative of 5x to the 4. We're also going to find that if you added, say, a number like 4 to that, what's the derivative of x to the 5? Well, that's 5x to the 4. What's the derivative of 4? 0. So this one would also give us the same one. I didn't have to choose 4. I could have chosen any number. So one of the things that we'll write eventually for this one, if we wanted to say all of the possible answers, we'll say x to the 5 plus, and we'll use c for any constant number. Any number is possible at the end. But this question just asked for a function, so this answer right here would be totally correct. You just had to list one of them. And if you had a favorite number, someone have a favorite number? 19. You could have taken the opportunity to use 19 in the question and be extra excited if you wanted to, because that also would have a derivative of 5x to the 4. So try this one. And obviously it would be 4x cubed plus 19. Okay, you don't need the plus 19, but if you wanted to, it would be there. You could have plus any number at the end, but that would be fine. So this is an introduction to the derivatives part. There's work here. Again, don't worry about this work next week. If you have time and you want to work on this, you can. But next week we're going to be studying a fair bit for our limits test coming up. But we'll work a little bit ahead in this unit, so when you do have free time next week for work periods and stuff, you can work on this or work on studying for your limits test.